Hello. I'm going to start fresh with this new install, and I'm pretty sure my computer's signed in administrator mode. And the firewall settings should be normal. I didn't turn anything off, I don't think. But I did order the SSL so that when I package the official dongle here soon, we'll begin to bypass these errors that pop up because it's not like a trusted program. So hopefully we'll get past that soon. But anyway, here's this. This is how it'll install. Agree. Installing, finish. Now, it uses your same username and password as an account. So once you purchase the license, a user it'll assign the computer you type this in to the user account, and it'll take up one of their devices. They get 2 devices currently. We might make it 3 because once you set up the Android app for the offline mode, it uses that as one of the devices. So the 2 devices is kind of for your computer and your phone or a tablet or something. Okay, so we'll start out with my user. There's unlimited installs on the same device. So like it'll know your computer hardware's ID or whatever, and it'll just like you could install it over and over again endlessly as long as it's the same computer or Android. Right now I have the developer menu still show up over here. I'll take that out in the official version. Highlights all the different stuff when you drag over it for development. So we'll just go to console. You can see these are the processes that it's run to just generate it and turn on. Last things it's done is triggered the truck scan down here. So some of the changes and updates, I have these just automatically set to kind of expand it because otherwise it's like, flat. So I set that to like 25, and then 50 in the depth seemed to be where it represented the object correct for the 60-degree beam angle on the truck scan. Again, the scan length was 30 samples, even though it was only a 3-foot space. And so I can show you why it's important to make this dimensions match the scan site, not necessarily the sample rate. So you go to plume, and we're on frequency, which is kind of just plain because that's the frequency data. And we've got the amplitude, and then you can kind of see the truck showing up in here. And then I like the average amplitude. It kind of refines the shape a little more. And now here's why it's important that we put the dimensions of the scan site into here, because the 30 samples, the scan distance and the depth calculation matter. So if we come over here to this and we put it to the size of the actual scan site, not the sample length, you can see we get the truck back. And then again, on max amplitude, we can see the truck here, but I like the average because it kind of refines the image a little bit. And so that's how we can get it to more like the true form. So that's what I've discovered so far with this particular scan. So there's the truck scan and how to tune the dimensions of the scan to the actual site regardless of your sample length. Okay. So now let's check out one of those scans that he told me to copy. We'll start with the first one. So these do look like a formation of some kind. I don't know your depth. These scans seems like it comes in at 80. So I'm not sure if this is 20 feet down, if you're seeing a like a culvert or something. I don't know. I don't know what you scanned, but here's this. And then if this length would have been less, let's say we did it 5. Yeah. And then again, what's the different ones? The frequency zone. There's a zone there with no frequency. I noticed in the other track last time I looked at them that some of the samples right in this area here may have had the ground balance or the gain was different for 2 tracks, and then you went and you adjusted it back and then did that. Or it could have been the detector was held higher above the ground during that particular sweep. See that, how the 3 scan number 3 didn't quite get as much of a bite on the tone um, for one reason or another. So you can remember how you scan 3 might have affected that. And then we could always, play with the data and try to refine the shape and find the settings that you think match what your scan was of. But I do notice that when the object is there, even though you mess the data up and drag it around, the form stays. So when there's an actual object there, it's kind of hard to actually destroy, um, the feature, even though you can play around with how it sees it. This one's pretty extreme there. Okay, so let's go to that other scan. Scan's pretty interesting. The average. I think this is the scan that I noticed. There was like a column across the center here. That's in the frequency mode. These track 3 and 4 may have had a different, um, either it was held higher above the ground during those sweeps, or the ground balance was adjusted or the gain was adjusted. So like if you have your live feed going and you ran some scans at this intensity and then you came in and ran a couple scans like this, it would show up and then as that difference. And then if you set it back and then continued to do just the way that this dark box appeared, you would end up with this trough in the data, because the detector settings or the gain was altered for these 2 sweeps, I believe. See, I just discovered one little bug. Once initiating this live feed, it thinks you're trying to make the scan from this, so it messes with your analysis of a chart. So I think you just have to reload it. There we go. Yeah. So there's kind of a plume there. I'm not sure what the object was that you were scanning, but that's what it looks like to me. You can always play with the feature and squeeze down on the data and try to get it to be more refined. I think the tighter that you can get the object to be, the more likely it's going to be the shape that you squeeze it into. Interesting. And, of course, you can still change to all the different kind of filters to try to help define it. On the truck scan, I found that this was the best setting, so I just preset it to that. So yeah, that's what these scans show up. They seem pretty cool. See this one here, you said you didn't scan it correctly, but we still get some kind of formation in the data. And then looking at these, go ahead and load this first scan. Um, it's easier to just load it from here. In this first scan, I was noticing that your detector, with this particular scan, the ground balanced tone frequency is set right here, 4,000 hertz, and then you can see that when the signal actually comes in on the amplitude reading, the frequency is dropping, which to me would show that it was probably like a void or something pulling the energy down. Um, so it's interesting to see that the signal is actually being pulled from the detector as it's gaining its readings. Pretty cool. Um, but a lot of times, like with the gold bug, the average hum is rather low, and then when you go over an object or metal, the frequency will increase up to the value of the alloy or whatever it is. Um, and then usually I'll have the hum going because it's next to a solid material, and if there was a void, there's less reflection, so the hum drops out. And so for the gold bug, the amplitude actually falls away when there's a void, um, and the frequency actually drops off also because there's nothing there to send a tone back. So um, I probably be really helpful if I had one of the an octave, and I could do a bunch of scans and practice with it quite a bit. Would be helpful. Um, but yeah, and so we already know how most of this other stuff works. But yeah, I just wanted to show you these scans on here and where we're at with the program. And I still have to debug the connecting to this, but right now I think it's working pretty good um, the way we've had it, even with this new calculation here. You can put this depth in, it affects the scale, and then of course our depth here can help us adjust within the range we've set, and the beam angle helps refine um, the structure of the object. So yeah, we should have everything covered in here to help determine. It's going to take practice. Each different detector is going to perform differently, and it'll take different adjustments to refine the object. But with practice, I think we can start to figure this out. Anyways, thanks, and I'll post this to you right now. I appreciate it.